So hi everyone, my name is Toby Mills. I'm the founder and CEO of a company called Entopy. We're a data orchestration and analytics business based just outside of Cambridge in the UK. And we've been in the digital twin space for about 7 years. The majority of that time has been in supply chain, but more recently we've transitioned to serve other market verticals as well, which we're super excited about. Now, the title of my talk is very much about how we see digital twin being the foundation for the intelligent enterprise. It's essentially pointing at the fact that businesses want to be more intelligent through data, but first the data needs to be put together in the correct way to unlock all of that. So I'll run through a couple of slides initially that just hopefully give some color as to how we see the world. I know we're in a digital twin community here, so it's probably worth just stating how we see digital twin and how we're using it. And then I'm going to go through 3 use cases, which hopefully add some color to all of that. So to kick off, we use the concept of digital twin to bring disparate data together in a meaningful way. The challenge is there's so much data and so many different types, so much variety, and the relationships between that data is hugely dynamic. So using a combination of RDF and ontology, we model data to reflect the real world. And when doing this, we think very much in terms of things, processes, and systems. So it's a logical segmentation, a way of thinking about this, right? So think about it a bit like this. Most people on this call will have a car, and you'll all be able to describe that car, right? So for example, I have a car, I can describe the make, the model, the color, the registration, etc. That car is what we would consider an entity or a thing. I too am an entity. I can describe myself, my name, my age, my height, etc. Now, me and my wife at the weekend went to Derbyshire, a bit of a story, right? But we went to Derbyshire. We left our house, another entity, and we traveled there in my car. Now, me and my wife traveling to Derbyshire is a process in which we both have a relationship with each other and the car within a given context, right? During our journey, we passed many other cars on the road network. That is what we would consider a system of multiple things and processes changing in dynamic ways. So that's how we think about the world, and that's how we model data using the concept of digital twin. It's a simple, logical way of looking at the world. Data is attributed to entities. Relationships between entities are created within given contexts. The graphic on the screen shows a similar example within the supply chain context. So at the top, we've got things. So you've got a consignment, a vehicle. Both entities, both have attributes, etc. So described by the data. And within the context of a consignment transport, the consignment and the vehicle have a momentary relationship between one another. All right, now, given the nature of reality and everything that I've just described and how dynamic it is and how these relationships change within given contexts, digital twin, or the concept of digital twin and the umbrella of technologies that it sort of encaptures, is absolutely critical to combining data to create the foundation for the intelligent enterprise. So at Entopy, we have developed over the sort of 7 or so years that we've been in this space, a suite of software and tools that help us to do that. They help us to unify data across an organizational ecosystem in a meaningful and discoverable way, whilst maintaining granular segmentation between the data, between potentially respective organizations. And we see it as very much a sort of question agnostic foundation. So once installed, the business, the enterprise, has the ability, has the power to ask or generate insights in the past, present, and future. So moving into use cases, the first one I'm going to talk to is the work that we've done with a multinational brand, helping them to optimize multi-vendor hospitality and spaces. So in this context, the twin is a food market, what we would consider an ecosystem with multiple processes and things within it. And the purpose is to unify both internal and external data to uncover insights that they haven't been able to thus far. And so far, we've identified a potential sales uplift north of $3 million per year in a single market. So this stuff is super, super powerful if you get it right. Now, the types of systems that we're connecting to, EPOS, so electronic point of sale, payment service provider, CCTV, Wi-Fi beacons. These are kind of internal systems that pre-digital twin were completely separate, post-digital twin brought together. And then we're colouring the model in further with external data sets such as weather and local events, helping them to gain this kind of rich insight that's leading to these kind of, the potential sales uplift figure that I mentioned on the previous screen. And where this is going is very much towards predictive, also using the digital twin to monitor and potentially even simulate interventions to help capitalise the insights that we're finding, as well as delivering responsive in-market displays and ads. The second example is the work that we did with a company called Fujitsu, helping them to deliver smart borders. In this context, the digital twin is a consignment journey. So very much a process, very similar to the kind of me and my wife traveling to Derbyshire in the car kind of process. Hopefully our trip was kind of less boring than this, but yeah. Now, the purpose here is more to bring data together from multiple organizations, right? So targeted data capture, bringing that data together to create a single consignment journey record. And once established, multiple stakeholders across the ecosystem can then get visibility of what they need, paving the way to pre-clearance of goods at borders. Now, the types of systems we're working with here, GPS, telematics, transport management systems, ERP, customs, etc. The key point here, I suppose, is that these systems tend to be owned by lots of different organizations. So maintaining the segmentation between data, or the granular segmentation that ontology provides, is absolutely critical. Once mobilized, we can capture events, communicate those events, and monitor things like carbon emissions and so on. Now, the twin has a UI, but it also has an API. And the foundational element here, which is slightly different, is that that API was used to run other data services, which is super interesting. And the final use case is the work that we're doing with the UK port to help predict freight and all traffic flows. So the twin here is very much the strategic road network, something we would consider a system, i.e. the roads don't change. And the system of running through the port is very similar as well. And there's elements of that built into the twin. And the purpose is to capture visibility of future traffic versus capacity, identifying pinch points to help mitigate congestion and be a bit more proactive in terms of communication across the sector. Now, before I move on, I want to introduce you to a concept called micro machine learning models. So this is where we start bringing AI into the whole thing. Now, the predicting port congestion is very difficult. It's a large, complex predictive problem. And the concept of micro machine learning models is to break large, complex problems down into smaller, more specific chunks. Bunch of reasons we do that. Obviously, working with smaller data, because data is very, very hard to come by in this particular environment. Maintaining segmentation between different organizations' data. But the big thing is getting a better model data fit. So the smaller the model, the more specific the model, the better the model data fit we've been able to achieve, getting much more accurate outputs, predictive outputs from those models. The outputs of multiple models are then orchestrated using the ontology, so using the concept that I've just described. So they don't necessarily have to be machine learning models. So for example, we could combine the outputs of an ML model with a staffing schedule, or we could provide algorithmic modifiers for things that we can't predict, like accidents. But you can also use the outputs of models to drive other models. So in a very similar way to how we've used someone else's weather forecast to predict traffic flow, we could use the outputs of traffic flow to help predict other things within the supply chain. So this is what the twin looks like. So we have a model, multiple micro models dotted across the strategic road network, delivering their outputs, types of systems we're working with, traffic cameras, RNS, and so on. The big enablement of digital twin here is being able to deliver micro models, giving higher predicted outputs, using a computational frame to pull everything together. And the use case feature that I want to talk to here is federation with the consignment journey digital twin that I mentioned previously. So those two can logically fit together, again, thinking about things in things, processes, and systems. So that sort of brings me to an end. I don't know if I'm probably over time now, but loads of other topics that I'd love to discuss, lots of stuff to talk about in this space. My contact details are below, so please do reach out. But for now, I'll close there, and thank you all very much for listening.